here just I want to talk about a very important point. When can we consider an object as a point charge? We talked before about the point charge. If we take a point charge Q, charged Q, positively charged, here in the case of a point charge, I would like to calculate the field created at the point A. You know, the field, we have a positive charge, the field must be out. EA as magnitude equal K Q absolute value divided by the distance square. The distance between the object and the point. Here we have R. Okay, this is in the case of a point charge. We have some cases we can consider the object as a point charge, because in general this formula EA equal KQ divided by R square can be used only in the case of a point charge. But in the case of an object, we cannot use the same formula. We have to take a small portion, dq, and we do the integration. Okay? But some cases, some shape, we can use or we can be considered as a point charge. Let me give you some examples about these objects. One, let's take a sphere. It's a uniform charged sphere. I mean, it's not a metallic, it's not conductor, it's a uniform sphere. Positively charged, I want to calculate the total field created at the point A. This is from outside, I see a sphere. In this case, we can consider this object as a point charge. I don't care if inside it's empty, it's full. I am looking from outside. It's a sphere, so this object can be considered as a point charge. Okay, so we can say here this system is equivalent, can be considered as a point charge Q positive, and I want to calculate the field as a point A. You know, in this case, E as a point A equals to K Q divided by the distance square. The distance is between the center of the object to the point. It's the same like this. So in this case, this object is considered as a point object, as a point charge. Second example, we can say we can take a shell. In the case of shell, let's say here we have a shell. I mean, it's an empty sphere. The sphere has a thickness. When we say shell, I mean we have two radius. We have the internal and the external radius. The internal is the distance between the center to the internal surface, and the external radius from the center to the external surface. Here we have A and we have B, internal and external radius. And now I want to calculate the field created at the point A. From outside, I see a sphere. I said I don't care about the inside, if it's empty or it's full. This case is a uniform charged shell. It's not a metallic. It's not a conductor. It's a uniform charged shell. I mean, the positive charge is distributed at any point on the shell. Okay, at any point on the shell. Here, 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 like this. Okay, at any point. So this object, this shell, can be considered as a point charge because from outside it's like a sphere. We can say this system is identical to a point charge at the point O. We have a point charge is Q positive, and I want to calculate at the point A. We get the same result. Here we have R, here we have the same distance R. We get the same field EA equals to KQ divided by the distance from the point A to the point O square. Okay, we get the same result. Okay, so we can take also another example. In the case, if we have a metallic sphere or a metallic shell, we get the same result. Okay, let me let's say here we have a metallic metallic sphere or conducting in this case the charges will be distributed only on the surface of the object. Okay, from outside I see a sphere. So in this case, if I want to calculate at the point A the field, we can say this system can be considered as a point charge. Here we have O. We can say it's like a point charge positive at O, and here we have A and the distance between equals to R. Okay, so R, we can say E equal KQ divided by R square. Okay, and also in the case of a shell, here we have a shell. In this case, also the positive charge will be distributed on the external surface of the object, only on the external, because we don't have any charge at the center. In this case, the charges will be distributed at the farthest, at the away from the center. Also, this system can be considered as a point charge. Here we have O as a point charge with Q positive at the point O. And this one is A, and we apply the equation of A, the formula of a point charge EA equal KQ divided by R square. We can say in general the spherical object can be considered as a point charge if we want to calculate the field outside the object. In all the cases, if the sphere is metallic or if the sphere is a uniform object. In all the cases, if the object of the sphere is a shell or it's not a shell, we can consider the field outside the object as a point charge. K equal or phi E equal K Q divided by R square. Okay, thank you.